Imagine an online shop has thousands of items in their database. When a customer is searching for a specific product, he or she wants to get the best match in a matter of seconds. How the computer can search through thousands of products in only a few seconds? This is where binary search comes to help. What is binary search? If you are familiar with the word binary, you know that it means consisting of two things or parts, a choice between two alternatives only, such as on-off, yes or no. So binary search can help searching through thousands of items fast. If you have to guess a number between 1 and 100, what will you do? Will you try to guess by counting from 1 to 100? Or will you randomly guess numbers? This will take a lot of time, and in the worst case scenario you have to call 99 numbers before finally finding the right number. With binary search you have to make only a few guesses to get the right number. Let me explain. In the second part of this video I will show you how to code binary search in Java programming language, but before let me show how binary search works. Binary search is a very popular programming algorithm to search through many items in a sorted array. This is very important condition. Before starting binary search, the array has to be sorted. What it means? You can do binary search on numbers in random order, for example. Before starting binary search, the numbers have to be sorted in order. So what exactly is binary search and why it is called binary? This searching technique will always start to search for the number exactly in the middle and divide an array into parts, left and right. For example, if you want to find a number between 1 and 100, the first guess will be 50, which is exactly in the middle. If 50 is the correct number, then searching will be completed. If 50 is not the correct number, then computer will get information if the number is lower or higher than 50. If it's lower, then the next search will be done from 1 to 49. And if it's higher, then the next search will be done from 51 to 100. Of course, the next guess will be 25 if it's lower than 50. Or 75 if it's higher than 50. In this way, we can, with just two guessing, eliminate 75 numbers from search. That's why binary search is the divide and conquer algorithm. Let's say the number we are looking for is 88. After the second guess, we got the information the number is higher than 75. Now we have to continue searching, but only numbers from 76 up to 100. Once again, we guess the number exactly in the middle, 88, and yes, this is the correct number. With binary search, we can guess a number from 1 to 100 with only a few guesses. This searching algorithm is very efficient in searching for any number in a long array. Okay, you already understand what is binary search, but how to write a code for binary search in Java programming language? Let me show you. Open your integrated development environment, I use IntelliJ IDEA, and create a new project. If you are not familiar with Java or programming at all, I will prepare another video where I will teach you the basics of Java. Now let's focus on the code. In programming, there are two ways of coding, iteration and recursion. Iteration is when a loop is repeatedly executed until the controlling condition becomes false, and in recursion we use functions calls to execute the statement repeatedly inside the function body. Code using recursion is shorter, therefore adds clarity, but uses small stack memory, therefore is slower. In this video I will show you both iterative and recursive binary search. First, let's go for the iterative version of code. In the beginning we start with class like in all Java projects. The next step is to declare binary search method in array. We'll search for a number, that's why we are using integer data type, and we are going to search for kx. Then we declare another integer variable as low and assign 0 value to it. And we declare integer variable high and also assign value to it. Please remember that in programming all counting starts from 0, not from 1. The low and high are beginning and end of our array. You can also use different names here, but they should have clear meaning. Very often words left for low and right for high are used. Do you remember the important rule that binary search can be done only on sorted array? So now we tell computer to check this condition. While numbers at the beginning are lower than at the end, perform binary search. While is a looping statement in programming that allows a block of code to be executed several numbers until a certain condition is fulfilled. Next, we tell computer how to find the middle number in the array. You can also find other ways of writing this line of code. However, by preventing it exactly this way, you can avoid integer overflow. What is integer overflow? Integer is a data type in programming that can only store numbers from. By writing the code as above, we don't have to worry about integer overflow. Now computer will start to execute our code. In Java, the code is always executed line by line. If the array is sorted and computer knows how to search for the middle number, we get first result. For example, if you are searching for number from 1 to 100, the first guess will be 50. If it's correct number, we tell computer to return the middle number. If 50 is not the correct number, the next line of code will be executed. There are two options. The number we are searching for is smaller or bigger than the middle number. If the middle number is smaller than our x, then the new law will be middle plus 1, which is 51. With only one guess, computer doesn't have to search through the left part of an array. If our x is smaller than the middle number, 50, then computer has to search only through numbers from 1 to 49, middle minus 1. With binary search algorithm, we can very fast reduce numbers to be searched by half. Computer will continue to search by reducing half of numbers until it gets the right number. If the number is not present in the array, the computer will return -1. Now let's write program to search for numbers in array. We start with public static void main method to run the program. Then we initialize the new object and declare an array of integers with our k value 5. Now we can print the result of binary search. If our k value is not presented in the array, computer will print element not found. And if our k value is presented in the array, computer will print element found at index plus result. This was iterative binary search. Now let's compare it with recursive binary search. We also start with Java class and declare binary search method in array. However, this time we also assign a low and high integer in the array. Two next steps are similar. First, we check if it's sorted array, and then we write code to find middle number. If middle number is our k, we tell computer to return middle number. If the middle number is bigger than x, computer will recursively search in the left part of an array by dividing it in half over and over again until the number is found. Otherwise, computer will recursively search in the right part. If the number is not presented in the array, computer will return -1. Let's try to do binary search on unsorted array and see what will happen. Let's try to search for k3. We get result element not found. And try to search for k12. We also get result element not found. However, obviously those numbers are present in the array. So do we always have to write our array in sorted order? No, we can sort it inside the program before performing binary search. We just have to add method array sort, and the array will be sorted. Java will also automatically import for us Java utilities arrays, which you can see on the top. This is how you code binary search in Java programming language. Binary search is commonly used in computer programming and is one of the most popular search algorithms. Another search algorithms are linear search and hashing, which I will discuss in another video. If you enjoyed this video and learned something new, please give it a like and subscribe this channel. My name is Anna and I will show you that programming doesn't have to be difficult. Now thank you for watching and see you in another video.